Welcome to a video example of Cauchy-Euler equation. So if we have an equation in the form right here, we call it Cauchy-Euler equation, whereas a are the constants and if the degree of coefficient is equal to the order of the derivative, so we can solve this equation using this method where we make this small substitution and reducing the variables, and by changing and substitution we can solve it. So let's say if we have an equation in the form like this: ax square y bar plus bx x y bar plus cy equals 0. We can solve it using the Cauchy-Euler method. So you can see here that the degree of coefficient equals to the order of derivative right here, and so we can easily solve it. Let's say we have an equation x square dy d square y over dx square plus minus 4x dy by dx plus 6y equals to 42 over x to the power 4. Now here we will substitute, let x equals to exponential to the power z and z equals to ln x. So you can see here that we can substitute instead of this and this. You can see that the second order substitution is d into d minus 1y, and this is the first order substitution, so we can simply substitute this instead of this. So it will be d into d minus 1 y minus 4 into dy into dy plus 6 into y equals to, so we substitute this value by it, so this will become e to the power 4z. This will become equals to 42 over e to the power 4z. So we can solve this equation by applying simple algebra. We will get d square minus 5 dy plus 6y equals to 42 into e to the power minus 4z. We can find the roots of this equation, which would be lambda equals to 3, 2. These are the roots. Now we can simply find the complementary function, which would be yc equals to c1 into e to the power 3z. As we substituted our value of x into ez, so it will be 3z plus c2 into e to the power 2z. We can change this, we can remove e by just x square, as you can see our substitution right here, and this by x cube. Now we have to find the particular integral of this equation, which would be y p equals to 1 over a function of the derivative, which would be d square minus 5 dy plus 6y into 42 into e to the power minus 4z. We can apply the rule of particular integral exponential rule. So we would get, by substituting the value of -4 by here, so we would get 42. We have 42 over here, so this 42 will cancel this, and the remaining you will get would be 4 e to the power -4z. So our yp in terms of z would be e to the power -4z, but we have to change it to get it into x. So it will be yp equals to e to the power, not e, it will be just x into power -4. So our general solution of this equation would be c1 into x cube plus c2 into x square plus x minus x to the power -4. So this will be our general solution of this equation. Thank you.